Okay, in this video we're going to continue with DeMoivre's theorem, but this time we're going to talk about roots. Now before we start, let's remember that if you had the square root of z, that's the same thing as z to the 1/2 power. Remember, fractional powers are roots? Okay, so with that, z to the 1/n power equals trigonometric form r times cosine theta plus I sine theta. Any complex number can be written like that, and then to the 1/n power. Now what DeMoivre's theorem says for this, for radicals like this, says that you take r to that root, it's going to be 1/n, and then you multiply times cosine of theta plus 360 degrees times k over n plus I sine, same angle, theta plus 360 degrees times k over n. So this is DeMoivre's theorem for roots. It's kind of the same thing. Remember, you're multiplying 1/n times the angle, but what's different is that you have to add 360k because there's going to be multiple answers. And so in this case, k is an integer. And so you start k with 0. K could be 0 and then k could be 1. So when k is 0, you could see it's just theta times 1/n. And there's going to be multiple answers. So just like with regular numbers, real numbers, if you take the square root of 2, right, there's 2 square roots of 2, the plus or minus, it's the same business. So when you look at what we're going to need to be able to do is this. So what if I wanted to take the square root of I, right? So the square root of I is going to have 2 solutions. There's 2 square roots of I. And I can rewrite this as the square root of 0 plus I, or 0 plus I to the 1/2 power, right? So that's what we're looking to do. Square root of I is the same thing as this. And so we'll apply DeMoivre's theorem to this. Step 1, just like before when we were doing DeMoivre's theorem, step 1 is to get trig form of that complex number. All right, so 0 plus I is thought of as a vector in the complex plane 0, 1. Okay, so 0, 1 is like right here, where r is equal to 1, and the angle here, theta, is 90 degrees. So it's pretty easy to see that 0 plus I, or just I, is equal to 1 times cosine of 90 degrees plus I sine of 90 degrees. All right? And so that's what I is in its trigonometric form. Okay, now we want to find 0 plus I to the 1/2 power, right? And so what we're going to have to do is take 1 times cosine of 90 degrees plus I sine of 90 degrees and raise that to the 1/2 power. So we get 1 to the 1/2 power times cosine of 90 degrees plus 360 degrees times k divided by 2, right? N is 2 in this case. Plus I sine the same angle. 90 degrees plus 360 degrees k over 2. All right, so this is DeMoivre's theorem for roots. So let's go back over here. Notice, let me change this to orange. All right, so notice when we had the power there, 1/n, we raise the radius to 1/n, and then we divide by n. So that's what I did here. We have a power of 1/2, so we raised the radius to 1/2, and we divided by 2. Awesome. Okay, so 1 to the 1/2 power, same thing as square root of 1. And then we have cosine of 45 degrees plus 180 degrees k. So basically you got to divide, so I'm right here, you got to divide both of these terms by 2 plus I sine 45 degrees plus 180 degrees k. All right, and then that equals 1 times cosine 45 degrees, whoops, plus 180 degrees k. You got to be a little careful with these, they take some time. I sine of 45 degrees plus 180 degrees k. So it kind of looks like we're done, but we're not. Okay, remember, we got to get 2 answers. We can't have k in the answer. All right, so I'm looking at this. I'm looking at this right here. This is kind of like our answer, but I can't have k. So we're going to start here with k, whoops, sorry about that, equals 0. All right, and then I'm just going to plug it in. So I get 1 times cosine of 45 degrees plus 180 degrees times 0. Let me do that again. I got my notation mixed up. So I get 1 times cosine of 45 degrees plus 180 degrees times 0 plus I sine 45 degrees plus 180 degrees times 0. All right, and then that gives me cosine of 45 degrees plus I sine of 45 degrees. And I know what cosine of 45 degrees is. That is square root of 2 over 2 plus square root of 2 over 2 times I. All right, and so that is the square root of I. That's one of the square roots of I. All right. Now what we have to do is plug in k equals 1, and that'll give us the other square root of I. All right, and so there we are in yellow. So you could see there I'm going to have to plug in 1 now. So I get 1, whoops. Yeah, so I get 1 times cosine of 45 degrees plus 180 degrees times 1 plus I sine 45 degrees plus 180 degrees times 1, right, which equals cosine, so 180 degrees plus 45 degrees is 225 degrees plus I sine of 225 equals, and then on a calculator you get negative, we are in Q3, so negative square root of 2 over 2 plus I sine is going to be also negative square root of 2 over 2, and I get negative square root of 2 over 2 minus square root of 2 over 2I. That's the other square root of I, right? So there's like 2 square roots of I there. All right, so if I plug in k equals 3, it'll start to repeat. So DeMoivre's theorem, it actually gives me this, which is a formula based on k to get the 2 answers that you're after. All right, so hopefully that makes sense. DeMoivre's formula gives you DeMoivre's theorem gives you that formula there, and then you start plugging in k's. All right, so what you can do is go to Wolfram Alpha and check your answer. All right, so that's what I'm going to do now. I'm just going to type in square root of I, sqrt of I, hit enter. And when I scroll square root of I, it gives me a bunch of junk there. So here's one answer. Didn't give me both answers. Here's both answers right here. So you got one answer in Q1 and one answer over here in Q2. So this is the negative, negative, right? That's the second answer that we got. And so here they are as decimal values. And so we get the same answer. These are the R and the theta here in radians. Now check this out. So for the square root of I, you get those two solutions. If you do, let me do I to the 1/2 power. Maybe typing it in that way is a little better because you get the same thing down here. Yeah, so here's our two solutions in decimal form. There they are. Now, if you do the 1/3 power, it's interesting to see the symmetry in the complex plane. When you do the 1/3 power, that would be the cubed root. There's three answers to that. And so there's one, that's the principal cubed root. But the other two are over here. So here they are, 1, 2, 3 solutions. And so you can see the symmetry in the complex plane. Negative I is a solution to that. All right, let's do the 4th root, and so on. You can play with the symmetry. It's actually kind of fun, kind of neat to see. Here's the 4 solutions, and there they are graphed on the complex plane. Cool. You don't need to know that. That's just interesting. When you go higher in mathematics, you'll study that. Okay, so let's do one from scratch. We're only going to be responsible for square roots in this class, but DeMoivres extends to nth roots. In any case, here we want to find the square root of 2 minus 3i. First thing you want to do is kind of think of that as 2 minus 3i to the 1/2 power. All right? Step 1 is to get trig form. All right? And so 2 minus 3i in trig form. Remember, trig form is just r times cosine theta plus I sine theta. And we already know how to do this. You just find r and you find theta. So I went ahead and did it already. R came out to be square root of 13, and theta came out to be 303.7 degrees. So we have cosine 303.7 plus I sine of 303.7 degrees. All right, so step 1 is to get trig form of the complex number. Okay, step 2 is to apply DeMoivres theorem. So what we really want are the two square roots of 2 minus 3i. So in brackets, we'll put the trig form, square root of 13 times cosine of 303.7 plus I sine of 303.7. And we're going to raise that to the 1/2 power. All right, so that's the thing. We got to raise it to the 1/2 power. So applying DeMoivres theorem, we need to take the square root of 13 to the 1/2 power times cosine of 303.7 degrees plus 360 degrees k over 2 plus I sine of that same angle. All right, so that's DeMoivres theorem. Notice here we raised the radius to that power, and then we also divided by 2. So that's the theorem. Now when we do the work here, we're going to have the square root of 13, which seems a little weird, doesn't it? All right, cosine 303 divided by 2, I already did it, comes out to 151.85 degrees plus 180 degrees times k. So remember, when you divide by 2, you got to divide both of these by 2. plus I sine the same angle, 151.85 degrees, plus 180 degrees times k. Perfect. All right. So step 3 is to start plugging in k's. Now there's only 2 solutions, so you always start your k with 0. All right, so when k is 0, so we got a formula, right? I'm looking at this formula right here. And we start plugging in k's to get actual values. And the first k you start with is 0. So when k is 0, we have the square root of 13 times cosine of 151.85 plus 180 degrees times 0, right, plus I times sine 151.85 degrees plus 180 degrees times 0. So basically we're plugging in 0 for the k. Get a little squished down here. Let me put this up here. Alright, and so that comes out to square root of the square root of 13. I'm going to go ahead and distribute this. So we have times cosine of 151.85 degrees, because 180 times 0 is just 0, plus square root 13 times sine of 151.85 degrees times I. Alright, now at this point I'm just going to do this whole thing on a calculator and then this whole thing on a calculator. Okay, when you do that on a calculator you get negative 1.67, and then when I do that on a calculator I got 0.90, just rounding off to 2 places, times I. Okay, so that's the first square root. Now let's get the second square root by plugging in k equals 1. And remember, I'm going back to here. This was the formula that DeMoivres gave me. DeMoivres' theorem gave me this formula to plug in the k's, and so that's what I'll do. Right, so for that one, we have square root of 13 times cosine of 151.85 plus 180 degrees times 1, right? Plus I sine that same angle. That's a 1 right there. All right, and so that equals, scroll up a little bit, square root 13 cosine of, well, 151 plus 180 adds up to 331.85, parentheses there, plus I sine of that same angle. Just plugging in. And so I think at this point, like I did before, I can distribute. So let me go ahead and distribute this. So we get square root of 13 cosine 331.85 plus square root 13 sine of 331.85, right, times I. Alright, so we got to do this on a calculator and then this on a calculator. Alright, and so when I do that I get 1.67 plus, and then that comes out to, actually that comes out to negative, so let me change that, negative 0.90i. And so there you have it. That's the second square root of whatever that was, 2 minus 3i. Right? So we're finding the 2 square roots of 2 minus 3i, and then so here they are. Right? Negative 1.67 and positive 1.67, right? Alright, so let's go to Wolfram Alpha and see if we got that right. Nice to check our answers sometimes. So right here, I want to do 2 minus 3i to the 1/2 power. Whoops. Right? 2 minus 3i to the 1/2 power. Is it equal? Let's see what we get. Square root of 2 minus 3i. This is the principal square root. Looks good. I want both of them, so I'm going to scroll down here. Here they both are. And so we're getting 1.67. Yeah, so this is our first one. Negative 1.67 plus 0.9. I rounded off to 0.9 when I did the calculator work. And then the other one was 1.61 minus 0.9. So the same two answers. There they are graphed on the plane. Awesome. Okay, so I know that's kind of complicated, but you could take it slow. Just as a quick recap, there's only one on the worksheet. So as a quick recap, you want to write the radical to the 1/2 power. Get the trig form, that's step number 1. Once you get the trig form, you can apply DeMoivre's theorem for roots. It looks a little different. It's got this plus 360k going on. Okay, so when we divide both of those by 2, we get a formula in terms of k. Once you get that formula in terms of k, right here, right, you plug in. So you start k with 0. When k is 0, you just get the 151. And we did all the math. And then we plugged in k is 1 right here, so we got 331, right? And then we did the math down there to get the other one. It's complicated, but you can do it. That is our last topic.